Hello everyone, this is Singh 𝐒𝐲𝐬 and today I am back with another video in which we will be discussing about retries. So retries is a general concept which we use to make our API calls more resilient, or you can say that, let's say, due to some reason these clients are hitting to this application servers and some exceptions occurred or timeouts occurred. Generally it is suggested that you retry for a request and there is a possibility that it will be successful on the retry attempt. Okay, so the idea behind today's video is that when you retry, are they really good or they are doing something bad for these application servers? So this is the idea or the context behind today's videos. Today's video, I have already discussed the retry strategies, what kind of retries we should do, exponential, backoff, jitter, all those things in previous videos as well. But I want to create this independent video in which specifically focus around if we do retries, what is the right strategy we should do retries via. Okay, another thing is what could be the potential issues which retries can cause if they are done blindly. Okay, so let's get started with our discussion. Before we move further, if you haven't subscribed to the channel MsDeep Singh, consider subscribing. We continuously make content around distributed systems, cloud infrastructure, so you will learn a lot of things. We also discussed a lot of architectural decisions which are made in large scale companies like Airbnb, Uber. I have created a lot of videos around Uber and Airbnb. Okay, so we will continue exploring that, so consider subscribing. You will learn a lot of things. Okay, back to the video. So what we are saying, retries, are they really good? Are they? So let's discuss that. So the idea is, let's take an example before we move forward. Okay, so we have a bunch of clients. We have a lot of clients. This is your load balancer which we have introduced, and there are a lot of application servers, which, let's say, we have 5 application servers we have figured out depending on the application, or like depending on the traffic which we are serving, or whatever the number of clients we have. So this is the number of servers we have come up with. Now the clients are interacting with the application server. Let's say they are hitting this particular API, let's say some API 1. Okay, and some identifier is sent. Okay, so this is the API which the clients are hitting to these application servers. Also, client has configured the retry policies. Okay, so let's say if some error occurs, let's say instead of sending a 200 okay response, it sent 500 or 400, or like, and not a successful response. In those scenarios, we have configured 3 retries. Okay, we have also implemented exponential backoff, and we have also introduced some sort of jitter. Quickly summarizing on what we mean by exponential backoff and jitter. So let's say, let's take an example. Okay, let's take an example here. Okay, so this is my API which I mentioned. This is API 1. Okay, this is my client and this is my server. Okay, server has exposed some sort of SDK. So whenever you are making this server1.api invoke, okay, whenever I'm invoking this API, whenever I am constructing this client for this server, I have configured these retry policies as well. Okay, if you have seen AWS SDK, how you use AWS SDK, you might have seen these kind of things. Okay, you construct the client and then you can also define the retry policy against this client. This is the object which returns, let's say, server. This returns a server object. This is your singleton method. This is your server object, which it is returned by this method where you are constructing this server object dot API. Here it will not be API invoked, it's just a constructing of server object dot API when you actually call the via parameters. Okay, so whenever this particular API fails, you have configured some kind of retry policy which is specified here. That retry policy is used to retry those requests. Now we mentioned, I was saying around what do we mean by exponential, backoff and jitter. So let's say you have configured number of retries as 3. Okay, so it means that once the call is successful, once the call has failed, it will retry again for 3 times. So the total number of invocations which we are making is 4. Okay, so first call failed, then you retry again. Second call, even if this fails, then you retry again. Even if this fails, then you retry again. If this fails, then nothing is done. The like call has permanently failed. Now exponential backoff. When I say exponential backoff, it means It means that instead of continuously retrying, okay, instead of continuously retrying, you introduce a delay, right? The delay is depending on some exponential factor. Okay, so let's say earlier you retried at t1, okay, then you retry at t1 plus 2, then you retry at t1 plus 4, then you retry at t1 plus 8, something of that sort, right? 2 it is 2 0, it is 2 2 2, it is 2 1, okay, it is 2 3. So some sort of exponential fact, by exponential factor you are retrying for that time period, okay, some delay you are introducing. Jitter, what we mean by jitter is, so you are introducing along with this exponential backoff, you are also introducing some random delay in between those requests. The idea behind jitter, like why we do jitter, is so that the clients, there are multiple clients which might be retrying, okay, so not all call comes at the same time. Let's say this particular call, this API invocation which you mentioned, failed for all the clients. So in that scenario, all the clients will retry at same time, okay, client 1, client 2 and 3, all the clients are retrying at same time. So even if you have implemented this exponential backoff, the application server are being hit at the same time. So to make sure that not all clients are making the invocation at the same time, you introduce some random delay, which might be, let's say, from 0 to 2 seconds. N is your maximum delay which you have allowed, okay, so this is the random delay which you are introducing. And depending on this delay, so let's say this client will make t1 plus 2 plus 0 second, this again client 2 is making at t1 plus 2.2 second, okay, something of that sort. So this way, this application server, like not all calls are coming at the same time potentially, not overloading the server. We also discussed some thundering herd problem, right? So if the server is hit at exactly the same time, there is a possibility that server is not able to handle that load, and we might face the problem of thundering herd in our server system, and then potentially entire system goes down, not serving any of the user request. Great. Coming back to our discussion. So what we are discussing here is, due to, like, we understood that what do we mean by exponential backoff and jitter. Now let's say, depending on these retries, client has configured this retry, client retries for API follows, let's say failure occurred due to overload on the system. Now what you are doing here is, let's say you haven't introduced some jitter as well, okay, or even though you have introduced jitter, what is the possibility here is that the system is, let's say there was already an overload scenario, okay, there was already an overload scenario on these application servers. Now if it is already overloaded and then you are also retrying, okay, let's say if the API failed for all of these clients. Now if you are retrying at this point of time, we are saying that system is already overloaded, okay, and you are making more calls at this time. So what you are doing, you are increasing the load on already overloaded system, you are increasing the load on already overloaded system. So this you should avoid, right? If a person is doing more work, you don't have to assign him additional extra work, okay, you have to reduce that work. So if the system is already under load, you don't have to increase the load. This can bring the entire application down, okay. So we have to somehow ensure that if the application is already under load, we should reduce the number of calls which we are making. Now how we can do that? It's kind of a shared responsibility in client and server, okay, we can't control clients always, but it is a kind of shared responsibility. Generally how every software works is that some responsibility is taken by the client and maximum responsibility is kind of taken by the server, because server in the end has to maintain its healthy state. Now let's discuss few of these things. So the first thing is, you have to actually identify which requests are actually retriable, okay. So let's say some request timed out, or in case you are sending an 400 request, okay, there is no point in retrying this 400 request because it will fail. Even if you retry it 100 times, it is going to fail because you are sending wrong parameters, okay, you are getting some invalid argument exception. So there is no point. Even in like 500 cases, you have to identify what are the retriable scenarios, okay. So you have to identify those scenarios in which you have to actually retry, and in those scenarios you should retry with backoff and jitter. We will also discuss the idea behind backoff. So we understood what backoff is. Now let's quickly discuss one concept of open systems and closed systems. Okay, so a closed system is basically where you are controlling the clients as well as the server. Okay, so let's say this is your server and this is your some internal server which is calling the system. Okay, so you're basically controlling these clients. Okay, and in case of open system, you are not controlling these clients, you are not controlling the clients. Generally this happens in a public facing software which you have created. Okay, so in those kind of scenarios you can't control the traffic, but in these kind of scenarios you can control the traffic. Okay, so backoff is really helpful in those scenarios. We should implement the backoff in both of these cases, but it really helps in closed systems. Jitter always helps, but yeah, it is hard to control the traffic in case of open systems because you can't predict like how many users can log in at a particular time. But in case of closed system, you can also ask the users to back off. Okay, just turn off the traffic, turn off the switch to not take traffic anything from them. Jitter we should always implement because in short we are introducing a random delay between the requests so that not all users are hitting at the same time. Now some of the other things, right? One thing is we created videos. There are like a series of 4 videos which we covered, which we talked about load shedding frameworks at Uber. We discussed around QALM, and there were 3 videos which discussed the architecture of Cinnamon. Okay, these are the load shedding frameworks which are being used by the Uber. Okay, we discussed those, and idea behind both those systems was that you identify which requests coming to this system, coming to these application servers are of higher priority. You only serve those higher priority requests, and even if you have breached those 5 priority requests, let's say I can serve only 5 requests at this time. Okay, so let's say 10 requests were coming in. Okay, out of this 7 requests were of priority. Okay, so you can serve 5 easily, you can do that. Now you have to also drop those 2 requests, so that's what we mean by shedding. Okay, you are shedding the load. So you identify the number of requests which you have to shed depending on some cohort and all those things. I highly recommend that you watch the video in which we discuss the architecture of Cinnamon, how you can identify which request to shed so that there is minimum impact on the customer experience. Okay, this is one of the thing, that you have some sort of rate limiting in place so that your servers are not overloaded. Great. Now coming back to the retry strategy, these are like additional things which you can do. But what you can potentially do at the level of retries. Okay, what you can do at the level of retries. So what you can do, the number of retries which you are doing, okay, the number of retries which are being done by the clients should only be done depending on what is the success rate of these application servers. Okay, so the idea is you use something called a token bucket algorithm. Now it's pretty simple algorithm. What you do here is, let's take a quick example to understand it. Let's clear the canvas a little bit. So the idea behind token bucket algorithm is, it's pretty simple. Okay, so you have a bucket, as the name suggests, you have a bucket in which you have max of, so your, let's say, bucket sizes. So you can have max of 10 tokens in this bucket. Now what is the logic of filling this bucket? Okay, so one is filling this bucket and one is like how you can empty this bucket. Okay, there is some logic in which you fill those tokens. Okay, and there is some logic to which you take out these tokens. Okay, so we have your client, we all have already drawn here. This is your client and this is your application server. Okay, so let's say you have invocation 1. Let's write it call 1. This is success. Okay, call to success. Okay, so once you have 10 successes, call 10 success. Okay, once you have 10 success, then you add a single token, 1 token you have right now. You can just say that every time a success is made, you have 0.1 being added to the bucket. Okay, so you have 0.1, then 0.2, 0.1, 0.3, finally you reach to token 1. So once you have 10 calls which are successful, uh, what you do, you add a 1 token to your bucket. Now whenever a call fails, okay, whenever a call fails, what you do, whenever a call fails, you check like if there are any available tokens in the bucket. This is basically your, you can say these are retry tokens. So you go to the bucket, you check if there are any retry tokens available or not. So my call failed, let's say my call 11 failed. So my call 11 failed, you go to the bucket, you see that yeah, there is one token available, you can use it. Okay, so then you go ahead and retry. Now let's say the call 12 failed. Call 12 failed. Now in this case, once you like you go and check in the bucket, you will not find any token, so you can't retry. So essentially what you are doing here is you are controlling the rate, at which the retries can be made to the server, potentially helping us to reduce that load on that system. Okay, so whenever there are successes, so like after the call 11 there are no tokens in the bucket. Once you will have like 10 successes in place, let's say call 12 to call 22 is success. Okay, then you will add one token, similarly token 2 token, and there is a maximum limit which you can add token. Okay, 9. So let's say the size is 10, so you add 10 tokens, and then if there are more successes, you just keep the bucket as it is. So this is how you can define. And there is one more scenario as well, like when you retry, what is the max number of tokens which you can use. Let's say you have defined 2, so if there are available 2 tokens available, then you can use them. So this is one of the important things we should consider when you are actually retrying. What is the kind of retry policy or retry algorithm which you are using to make retries to the servers. So this is all about like retries, and if they are good, they are good. If they are done right. They are bad, they can be really bad, and they can bring the entire system down. They can create the retry storms which we generally talk about, and can bring the entire application down, impacting all the customers. So they should be done, but with care and lot of considerations which we discussed in this video. So this is all about today's video. We will meet again with new architectural decisions and like how you can design multiple components. So till then, stay safe. Tata, bye bye.